Assalamu alaikum, guys. How are you?
Walaikum Assalam, sir. How are you?
I'm fine. Mr. Ahad, from some days you are absent from the classes.
Yeah, जी sir. Basically, sir, there was a power shortage and a connectivity issue, so that's why I'm unable to join the class.
Okay, okay. Mr. Amar, uh, has you work on the the task I have assigned to you yesterday?
सलाम सर।
Wa Islam.
जी सर, वो मैं वर्किंग कर रहा हूँ। आज इंशाल्लाह कल तक मैं आपको ग्रुप में भेज दूंगा।
Okay, thank you. Thank you. Great. Okay, guys. Yesterday we have studied about the data sheets. Somehow the important factor from the data sheets. And today we will work on the PVsyst interface. Then from the tomorrow we will proceed a regular uh, project on the PVsyst. With the help of the shading analysis we have done in the SketchUp files, we'll export the Colorado files .dae files, and then we import in the PVsyst and do the thermal assessment. Sorry, shading analysis, 3D shading analysis of the in the PVC. So today I'm just giving you the overview of the interface of the PVC. Then we move on to the move forward in the next classes. So I'm just sharing my screen and we move forward. Again, yes. So basically, this is the PVC, which is the crack version. I'm just opening that one. So here is the basic interface of that, like it's just okay. Here is the file. Now at that time, if we go with the paid version, it around 8 version is available in the market. But because we are doing the crack one, uh, we have to stick with the crack version because if we pay the dollar, then it is very good. But as a person, it is very difficult everyone to pay the dollar to the different companies since they have 1 year mm, membership, and after 1 year their license will be expired. So that is why it is very difficult for everyone to do like that, this type of things. But if you want to practice any, you want to be in the good form, and you want to be excellent in the PVC, you want to become excellent in the PV system, you can add, or you can, like, with no need of the purchasing the PVC software, you have to just practice on that crack version. When you will be, inshallah, you will be going into the company like Mr. Amar and Mr. Ahad, you are working in the companies. Company will pay the price of that software, and will you will they will buy the software and you will use that software. Uh, but as the individual, this crack will be workable for everyone. So it is the basic interface of that software. When guys, just 2 minutes. I'm just coming back. I just remember forget to give my glasses. I'm just taking glasses and come back just in 2 minutes. So guys, I'm just talking about the license version and crack one. Like where I'm currently working in my company, we have just two license available in our company. So two persons from our side. One is the overall department lead. They have the paid version in their computer, and the other one, the other people is they are doing the biddings. They are using that paid one software, but our all the other guys will be using that crack one. When we needed that one, we will make the PVsyst on that paid one, which we have to submit to our clients. But as an individual, like I am just working for the different uh, projects on different my client. You will see that I have just made that one, like this one, this Wazirabad, like Wazir Bagh, like this time. They are all the thing. They are projects are my individual project, which I am current, which I have worked on. Cold store. This basically as a training, I have made that project. 610 kilowatt system is for the my project by client. They all are the for my client. So these are the database like grid connected systems. You know very well about that systems, grid connected, and I have explained all the things. Then we have the standalone systems, and then we have the pumping systems, and then the database, the tools, and the measuring data. Basically, grid connected, we already know about the grid connected. Standalone, we know about that. Then the pumping system. Pumping system, like you have seen that in our agricultural lands, we are using the solar system to use the pump, um, to, and they will the pump will be driven through the VFD drives. Solar pumping inverters, like very variable frequency drive, and this will be driven by the solar systems. So uh, as of now, I don't use this this pumping system, because we have to need the water systems. First of all, we need this data, water design, water needed, how much type of the water you needed. Then you have to propose the system. Then you have to do the detail losses. Like if we just mention the size of that anything, and we will put any location. Like I have just put that location, and I just made that one. Then orientations, like I have just mentioned that one. Now we have to fill that one. First of all, we have to fill that data, like the pumping hydraulic circuits, static load, then the specific downtime, maximum flow rate. These are the values you have to put in your PVCs. Then you, like you have see that in the feeding level, like this is the pump available, maximum depth, pumping level, and then the static. Okay, these are the water requirement, and then you need to the water needs and had definitions, like every daily, the whole year needs, and the whole year pumping. Uh, so when you will be putting that value, then you can enable the systems, and then the detail losses. Then you will perform. Okay, basically pumping, I have seen that data in the pumping, but most of the time we don't use the PVCs for that purpose. We have only used that for only the grid system and standalones.
Sir, sir,
Mostly,
is this pumping system is
yes.
related to solar or is it an individual system?
Basically, pumping system means that the pump, like in the agriculture field, like submersible pump or centrifugal pumps, will be driven by the uh, variable. frequency drive, which is driven through the solar system, because that variable frequency drive Gentech, mostly Gentechs will be, or Fuji or other uh, devices are used with the pumping to pump the water from the ground level, and that will be driven through the basically the DC system, and DC means the solar system, because you have seen that the tube well system will be mostly running through the different, like the generator system, like the one is the means that on the diesel and other things, but now these days they will be driven through the solar system through VFD drives. Okay.
Okay, sir, got it.
Okay. So standalone is simply, if we click on the standalone system, you have to just define the name of the project, then you have to define the side of the systems, and this will be automatically uh, they fetch through the, then you have to save that, then you have to give the orientation of the projects, like how much is the azimuth angle, how much is the tilt angle of your solar power plant. If you have multiple like uh, unlimited track or seasonal unlimited shares, any option. So you have to put that tilt angle and then azimuth angle. Then you have to design the user need. User need means you have to put the consumption. You have to put the consumption of the system, like number of the number, like we have LED. Two number of LEDs are installed in our home. What is the power of one LED and usage hours? Usage hours. Then you have to define that load, and then you have to decide the hours in the time zone. Like it will be working in the night time, it will be working in the daytimes, and how we will use that one. Then you put okay, okay. Then you decide the systems. Like you have to decide the storage system, what is the capacity voltage, and how many batteries are connected in the series, and how many batteries are connected in the parallel. Then you have to decide the solar systems, and this controller systems, and then backup times, like how many backup time you have. If you have your genset, like use backup genset or other thing, then the simulation sketch, like this type of sketch. Then you press OK. Then you decide this is the system types. Okay. Then you will do the run the simulation of that software, and you will get that. Now I'm just over giving you the overview of that one. Like you have this option, like new one, new projects. Then if you have projects available in your directory, like you have these two project in available in your directory, you will select from anyone, and you can, like we have selected that one, and we have uh, opened that solar systems project, which I have already made that one. This is the save options, that one. Then you have the import option. Like if you want to import the project from the external drives, if you have any project available in your laptop, you will import that software, sorry, project in your uh, PVsyst. But it should be in the zip file, in the zip file. It will export that project. Then you have the export option. This is the export option available. Now you have just this option available. Okay. Now you just click on that export options. Okay. Basically, I think what is the issue that one. Okay, now then the project setting, like you have to define the lowest temperature. What is the lowest temperature of the site? Basically, albedo value is the like the how much value how much rays are uh, reflected back sun rays will be getting from the ground side. How many number of rays will be reflected back when they strike on the ground. Like we have, you can see that if you are this value, albedo value is higher than higher side. You mean that you will getting more radiance back strike on the ground, and they will reflect back to the for the bifaciality factors, like backside of the PV modules will be working, but it value will be low, then the production and bifaciality and other factors are lower side. So you can see that urban situation, like we have this value like 0.14 to 0.22, rural 0.15 to 0.25. Fresh grass, this is fresh snow, this one. Like you can see that like the white snow available. You have seen that when you will go into the northern areas, you have seen that when the sun is shining, you are they are like giving you the very heat type, like this type of and uh, very teasing type of sunlight. This type the issue. So means that when the sun rays strike on the snow, they will reflect back. They will not absorb in the snow. Then the wet snow, like this is the value. Right, yes, that wet side. You galvanize steel, very dry galvanized steel, like this type of value. You have to select that value from that tables. Or if you have any albedo study available for that site side where you are installing our solar power plant. Now you can see that I have made a one project on that. You can see that at the top you can like simulation is the cover page, project name, and then variant name. This is basically the variant name. This is variant. You can like you have created a one project and you are doing the different variation in your PVC simulation. You can make number of different variation in that projects, and you will use that variation at that time when you need it. Then size and then the side name. Here you can see that they have just given you the side coordinate, then albedo value, then the weather file, then this type of that. Then you have number of PV modules, their ratio, then their technology like the battery technology, number of batteries, voltage, and then the capacity. Then they have useful energy from the solar, like they have value result summary. Mein. Missing energy, excuse unused energy, specific production like this type of available solar energy per year, this PR value and solar fraction value, like, and you have this system available, number of PV modules and the number of batteries and then controller, the series. Then you have the losses available in that one. Then you have user defined value like PV and other things when they are working on that. Then you have this summary value. Okay, this is the basically PVC's report. Now we just go back to the grid connected systems like we have. Like we if we want to export that project, like you can export that project and send to any client. Tell me why they are not. I don't know why. What is the reason why they are not allowing uh, export of that solar project? And then side variant other things I have explained that one. Here is basically the project name where you will put that name. Then you have to select or add the side of that uh, side of where we are installing our solar system. Here is plus sign available new site, and this is the open site, choose site, which is already available in your PVsyst directory. And weather data, this is basically used to uh, upload the database. Like here, I have just selected the Meteonom files, which is already available in the database of the PVsyst. But if some client will give you the uh, different file like the solar GIS file, so we have to upload that file in your uh, PVsyst. Tomorrow, when you are we are working on that. Tomorrow on Friday, we will. I have just my experience projects, which I have the TMV file. We will upload that file and how we will they will work. We will be using that one. Then this is the orientation I have explained. Then the system options available, like inverter selection, and then uh, the panel selections available. Then we have the detail losses, like which I have already explained in the yesterday class. We have this value, thermal parameters. Like in the thermal parameter, you can see that we have just dome available, semi-integrated with the air circulated ducts behind, and then the integration with the fully insulated back. Free air means that our solar power plant, on the rooftop, in the ground mounted, we just select this option. In the domes option, we select this option. If we have semi-integrated with the air duct behind, we can say that the plant where have partially air circulation, not fully. So for that one, we select that option. But if we have fully back insulated, like this type of the shed type, air not circulate, then you will select this option, fourth one. Then we have the ohmic losses, like we have DC ohmic losses, which we have to calculate the DC voltage drop when we are doing the cable sizing. On that basis, you will put that cable losses, average basis. Then you have the AC ohmic losses, mean that your AC cable losses, voltage drop losses. On the average basis, you will put that values. Then you have this transformer available, like medium voltage transformer. They are study these node load losses and load losses in the machine subject of the engineering field. Then you have this type of if you have the HV transformer available in your solar power plant. If not available, you just unclick that option. Then you have the module quality, which I have already explained. The module quality, it is a this is foreign, like they have explained that one. Like module quality, we will choose if we have -3 to +3, it will be 1.1. If we have starting on 0.0 to +3, it will be basically the positive tolerance, like this type of values available in a PV systems, like data sheets, which I have just show you at the top of the PV modules data sheets. If we have -3 + 3, then you have to choose 1.5%. But if you have 0 2 plus 3, that means that it is minus 0.575, but we just put that value below that one, because if this value is minus, then means that your system is gaining energy, like your PV module power is on the gain side. Their power is higher than the STC values. But if these values is if positive, then means that the power is on the lower side. Then you have the LID loss factor, which I have explained in the yesterday class. Then you have the module mismatch losses. It is very difficult. It is very difficult because, as per our experience, we don't like confidence on that value, because in some projects it will be like zero point 0.8, like 0.3, 0.4. They are not confirmed to everyone, because we have contacted to some other company regarding that point, because this is totally depend upon the PV module working when they are in the working phase, how much they have difference. Like if you click on that one, and we have already contacted to the PVsyst company, and they don't sure about that value. Basically, due to the fact that the sorting of the module or cells, the lowest temperature drive the current of the whole strings. Identicals. So basically, when you are connecting the PV module in the strings, the PV modules connected in the string, they are not basically same with the characteristics. Basically, when we have seen that in the flash test report, they have the different value, like the current values, current and voltage, they have difference. So I will explain like somehow to show the value. And this is the string voltage drop. It is basically the lowest and uh, shortest string voltage drop, like the difference. Like if we have one string have the length is like 100 meter and one has the 20 meter. So in between that value, we can, if we want to detail study, you can just click on that one. Just click on that detail study. Now you have like they have these values. They have minimum length is 20, maximum length is 30. Then their mismatch loss is around 0.26%. Like we will change that value like 150 meters if we have. Then this value has become 0.03. Sorry, 300 meters. Sorry, like 100 meter. 0.6, 0.6. You can calculate that value from that one. Then you have the soiling loss as per the site conditions. And then this is, you have to just click on that one. Auxiliary, basically nighttime consumption or daytime consumption of solar system for their auxiliary, like if we work on the large scale project, you have seen that most of the like SCADA system and other things like the lights, uh, the weather station, they needed some power from the solar power plant, and this power will basically fed feed through the solar system. So that means we have to consider this loss in our PR performance, because they are used in that solar power plant. Then the aging factor, like how our solar panels will degrade. Like I have just explained 0.4% annually. And then unavailability means that your system is when they are available. So it is around 1% or 2%. Mostly in the large scale project, we use 1% as unavailable systems. Then you have the this self consumption means that daily working. If we have the separate battery system like PCS, these days Mr. Amar is working on that. Like a large scale project, they have no hybrid system. Basically, they have separate best system and separate on grid system. and they combine on the grid side. Then you have to put that self-consumption and the storage systems. You can define that one. I will explain everything, but in details when we are working on the by projects. Then we have the near shading options. This option, constructions. Then you can import that one, Colorado file, this one, DA, PVC file, and 3ds file. And then we have the simulation options. So tomorrow, inshallah, we will work on one projects, inshallah, and then we will add everything in one solar projects, inshallah. So if you have question, you can ask. But these today, not much more questions. But from the tomorrow, inshallah, you have more questions. Any questions? Are we end up of our today class?
Sir, last lecture video was not uploaded yet.
Tomorrow, inshallah. Today I'm busy in some project working. Inshallah, tomorrow I will upload these both lectures, inshallah.
Okay, thank you.
Okay. Okay. I think tomorrow we will more in the discussion phase, inshallah. Because when we are preparing one simulation report, then you have much more questions. Okay. Okay, guys. Inshallah, we will meet by tomorrow class, inshallah.